In this lesson, we're going to solve an example problem and apply all Newton's laws of motion. Alright, let's go through our problem. Consider that the following system is in equilibrium, and despising the mass of the cables and pulleys, what are the angles 1 and 2? Okay, let's think about the problem first. We know that it's in equilibrium, and by Newton's first law of motion, it means that nothing here is moving. There's no acceleration. Also, let's identify all the forces acting in the system here. And these are the forces. We have the weight of each block and the tensions in the cable. We know by Newton's third law of motion that for every action there's a reaction. In this case here, the weight of block number 1, for example, as a reaction we have the tension 1 in the cable. So let's go for equilibrium in the y direction. Okay, for block number 1, we have that the tension here, the tension force, is the same as the weight force. And the same happens for block number 3. Now for block number 2, we know that these tensions here, they are transferred through the cable. And because everything is in equilibrium, we know that the weight of the block number 2 is the sum of the tensions 1 and 3 in the y direction. And that's the equation number 3. Alright, so what do you want here? We want to find the angles. So let's solve first for the forces here. So we can substitute the tensions on the cable by the weights of each block. So we can just substitute this on equation number 3 and we have something like this. Just adding the values here, we can find this equation number 4, associating the angles 1 and 2. Okay, let's go now for equilibrium in the x direction. Because we only have tensions in the x direction in block number 2, let's isolate it. And doing the same thing, we have that T1 cosine of angle 1 equals T3 cosine of angle 2. We also know that the tensions are related with the weight of the block. And then we have equation number 5. Alright, now we have two equations and two unknowns. Because we're dealing with cosines and sines of angles here, we need to remember one of its properties, one of its trigonometric properties. And we need to remember that the sine of an angle squared plus the cosine of an angle squared equals 1. Alright? I'm isolating the sine squared here because we're going to use it later. Alright? We're dealing also with sine and cosine squared. So one thing that we can do, we can square both equations. So from equation number 5, squaring both sides, I'm just passing this 2 here to the other side and maintaining it in the fraction format to make it easier. And now we have equation number 6 derived from equation number 5. We can do the same for equation number 4, squaring both sides of the equation and passing this blue term here related with the angle number 1 to the right hand side. Okay? Okay, so let's start with equation number 7 here. We can just change it a little bit. I'm putting the right term here on the left side and the left term on the right side. Our goal is to find first the angle number 1. So we want everything here to be in terms of 1. So everything here needs to be blue. Alright? So left hand side is the same. Here we know from the trigonometric property that this sine here squared actually is the same as 1 minus the cosine of this angle squared. Alright? And I'm leaving this 2 squared here on the outside. Okay? So why am I doing this? Because if you remember from equation 6, this cosine here in green squared actually is the same as the cosine of angle 1 squared times this fraction here. So I'm just adding this equation number 6 here, and now we have what we want. One equation and one unknown. Also, we're dealing now with sines and cosines, but we want everything to be in terms of sines. So we use again that property and transform this cosine here into 1 minus the sine of the angle squared. Now we can just keep calculating and doing some simplifications, and we can find that the sine of this angle, of the angle number 1, is 0.6. Therefore, the angle 1 is 36.9 degrees. Okay, now we have angle number 1. It's easy. We can go back to equation number 5. Just add the cosine here of the angle. Just add the angle here, and we can find easily that the cosine of angle number 2 is 0.6, and then the angle itself is 53.1 degrees. These are the results. We can just remember here the system we're dealing with, and we could find now all the angles between the cables. As an exercise, you can also calculate all the tensions and weights of the system, all the forces that are being applied. Okay? That's it. Thank you.
If you found this video helpful, remember to subscribe and stay tuned.